Hey, welcome to today's lesson. Today's lesson is on the area of trapezoids, and you have guided notes to go along with this. And I'm going to really encourage you to make sure when I ask you to try a problem that you pause the video, that you try the problem, and then you unpause the video to see how you did compared to what I did. Even when we're trying the examples, before you watch me do an example, try it yourself, and then unpause the video and see if you and I did the same thing and got the same result. So let's start out talking about trapezoids and knowing what shape we're really describing. So a trapezoid is a quadrilateral. Quadrilateral literally means four-sided figure. So it is a four-sided polygon with one pair of parallel sides. Just one pair of parallel sides. Remember, if it has two pairs of parallel sides, it would be a different shape. It would be a parallelogram. Now, in a trapezoid, there are certain names that we give these sides. The two parallel sides are called bases, and then the non-parallel sides are called legs. So a trapezoid has two bases, the parallel sides, and two legs, which could be different lengths. Now, there is one type of trapezoid that's somewhat special and deserves its own name, and that's an isosceles trapezoid. And an isosceles trapezoid is a trapezoid where the legs are equal in length. And you can see the notation of these hash marks are saying that these legs are equal. So let's jump in and let's just try a problem to find the area of a trapezoid. And no formula is given. Let's just see if you can figure it out on your own. So here's a trapezoid right here. We're going to, since I called them trapezoids, we'll just assume that these are the parallel sides, and this trapezoid here happens to be isosceles. So why don't you see if you can get really creative and very clever and find the area of this trapezoid, not knowing any specific formula for a trapezoid. So pause the video and give it a go. Welcome back. Well, I imagine one thing that you could try is you could try to frame that trapezoid in using a rectangle. And so you see I can build this rectangle that frames in the trapezoid. Now that rectangle clearly has an area bigger than the trapezoid, but if I took the area of that big red rectangle and I subtracted this right triangle, I subtracted the area of the triangle here on the left side, and I subtracted this right triangle, I subtracted the area of the triangle on the right side, I think that would be the area of the the trapezoid. So let's try that and just see what happens. So the area of the parallelogram. Well, we know there are three things I ask for every problem. The first is I want to see the formula, and that's base times height. And in this case, we see that the base is 20. Again, remember, it's the big pink rectangle. And the height is 8. Now, we're going to subtract the area of a triangle. And again, I want to see the formula we're using. So we're going to subtract the 1/2 the base times the height. And we're going to subtract the area of the triangle on the right, which is 1/2 base times height. So we're going to subtract... now this triangle here, I think we have to do a little bit of planning. If this distance is 10 and this whole thing is 20, can you figure out that this has to be 5 and this has to be 5? And so that would be 1/2 times the base, 5, times the height. Now the height of this triangle is 8. It's the same as the height of the parallelogram. And same thing over here. And so the three things I want to see: formula, the numbers you plug in, and then the answer. So when I clean up these numbers, I end up getting 120 square inches. Now that, my gosh, that's a lot of work. But let's see if you can do it on your own. I have here a second example, and I'd like you to try to see if you could follow the same type of strategy to find the area of this trapezoid. So go ahead and pause the video and come back and let's see. Welcome back. Again, I think one strategy you can do is you can draw a a rectangle around that trapezoid, and maybe your strategy here is similar to above. You could take the area of the purple parallelogram and subtract the two side triangles. Now the area of a parallelogram is base times height, and we're going to be subtracting, the two triangles, so minus a half base times height, and minus a half the base times height. And now the big parallelogram has a base of 24, but the height, well, the height in this case is right here. This is the height. It's not 13, but it's where the right angle hits between the two bases. That purple line is the height. So how do we find the height? Well, if you'll notice, with this being 24 and this being 14, they differ by 10. And if we split those up, that would mean this is 5 and this is 5 over here. And that lets us use the Pythagorean Theorem. We know 5 squared plus h squared is 13 squared. And so we can use the Pythagorean Theorem on this triangle to the left to find h. And long story short, it turns out h is going to be 12. That's one of those Pythagorean triples we've been talking about. But you don't have to memorize those triples. You could just do the theorem. So the height is 12. And over here, this triangle on the left, that is minus a half, the base, which is 5, and the height, which is 12. And the triangle on the right, the base is also 5, and the height is 12. And so you end up getting, for this particular case, 228 square centimeters, which is great, but my goodness, that is a lot of work. And if there was an easier way, that would make life easier. And gosh, there is an easier way. Why don't you put your pencils down and just watch for a second, and let's see if we could figure out an easier way. So here's my trapezoid. I have a base on the top and a base on the bottom, base 1 and base 2, and I have the height marked. And I'm going to do with this trapezoid what we did with the triangle earlier last week. And that is, I'm going to reflect it over one of the sides. And if I take this trapezoid and I reflect it over one of the sides, do you see how base 2 flips up and base 1 flips down? But more important than that, we end up getting this shape right here. And I think if you really think about it for just a little bit, you know what that shape is. That shape is a parallelogram. And the area of that giant purple parallelogram is the length of one of the bases times the height. Now, the length of one of the bases is base 1 plus base 2. That's the length of this entire base times the height. And that's the area for this purple parallelogram. But I don't want the purple parallelogram. I just want the trapezoid. Well, what's the relationship between just one trapezoid and the entire parallelogram? Well, the trapezoid is half the parallelogram. So right here, this is the formula for the area of a trapezoid. Now, this is a great time for me to tell you, you don't need to memorize these formulas. We will give you the formula for the area of a triangle, the area of a parallelogram, the area of a trapezoid. All you have to be able to do is use those formulas. So let's dive into 3 examples and see how this formula makes things go a lot faster than what we did in the previous page. So the first example I'd like to look at is the first example from the previous page. And basically, if we had this formula, actually I shouldn't show you this, but if we had this formula, we could say the area of the trapezoid is 1/2 the sum of the bases times the height. So it's 1/2 the sum of the bases. So one of these bases, it doesn't matter which one of them is base 1, 20. The other one, and again, it doesn't matter which one's base 1, base 2, is base 2, 10. And the height, look for the right angle, the height is 8. And if you just plug these numbers into the formula, you get the area in seconds. So let's try one now where I give you a problem. You haven't seen it before. And let's see if you can use this formula. So here's problem number 2. And this is a trapezoid. So why don't you pause the video, try it out, and see how you do. Hey, welcome back. So in this particular formula, again, I'm going to write out in step 1 the formula I want to use. This is a trapezoid. The area of a trapezoid is half the sum of the bases times the height. Now, bases. The bases are the parallel sides. So one of these is base 1, one of them is base 2. So that part was kind of easy. The tricky part here is the height. Well, the height, we look for the right angle. This is the height right there. That purple segment is my height. And so that purple segment isn't 5. So what I'm going to do is I'm going to take that height, and remember, anywhere along here, that purple segment's the height. If I move it all the way over to there, now I can say I have a right triangle. And this right triangle here allows me to use the most famous theorem in math, the Pythagorean theorem. So let's see if we can use the Pythagorean theorem. First of all, I need to know this side. And if this is 8, then down here this would be 8. But if the whole thing is 12, that makes this 4. So using the Pythagorean theorem, I can say h squared plus 4 squared equals 5 squared. And you can do the calculations, and it's going to turn out h is 3. So, plugging my numbers in, I have a half. I know that the bases are 8 and 12, and the height is 3. And that gives me an area of 30 square centimeters. Let's try one more problem. And here's the last problem. Number 3. Why don't you try this on your own, and then come back and let's see how you did. Well, welcome back. I hope the first thing you did is you wrote down the formula. Now the second thing you have to do is you've got to find the two bases. And this one, the two bases are pretty easy. There's one, there's the other. Remember, the bases are the parallel sides. So we have a half. Oops, my 1/2 isn't showing. It's trapped in there, so I'll just write it here. This is 1/2. And then we have the two bases, 26 and 12. But the height's not 25. So what I'm going to have to do is I'm going to have to come here. I'm going to have to drop this perpendicular straight down, and this is the height. Now, that's the height. And remember, this is also the height right here. So, let's see. This is an isosceles trapezoid. I can tell because of these hash marks. So this is 25. And if I take this 12 and drop it straight down, that's 12. Well, if the whole bottom piece is 26, and I've already accounted for 12, then that means that I have 14 inches left to be split between these two bottom pieces. So that would make each one of these bottom pieces 7. And I can now use the Pythagorean theorem. I can say 7 squared plus h squared equals 25 squared. And again, use your calculator and find h. Spoiler alert, turns out h is 24. So we now have the height is 24, and we can find the area. Okay, so those are your notes today. Why don't you go ahead and dive into your homework and see how you do. Good luck.